Hi everyone, welcome to Unit 1, Day 10. Today we're going to be learning how to describe a graph, this time with intercepts and mins and maxes, and we'll talk about what those are in today's lesson. Our content goals, today we want to review equation solving, and then we also want to be able to find and describe x-intercepts and y-intercepts of a graph, and we want to be able to find and describe minimums and maximums. All right, so we're adding a little bit to what we're doing with describing a graph. Yesterday we talked about x-intercepts and y-intercepts and where to find those on a graph. Today we're going to be adding in minimums and maximums. All right, here we go. Let's start off with our review, which is just going to be a little bit of equation solving again today. Last time we did really simple two-step equations, but today we're going to add a couple things such as combining like terms and distribution. So watch me do some of these problems below. All right, so we have an equation. Remember, what it means to solve an equation is to find a value of x that makes the equation true. So essentially, we want to end up with the same number on both sides if I were to plug that x into the original equation. The way that we find that special value of x that makes the equation true is to get x by itself in the equation. All right, so here we go. I'm going to start off. I always like to draw a line kind of dividing the two sides here, and then I'm going to choose a different color to work with. All right, and you'll notice over here on the left-hand side that we have three different things with x's in them, right? We have a 4x, we have an 8x, and then we have a negative 7x. So this is an opportunity to do something called combining like terms. All right, so right here, combining like terms, and this is important. What we consider to be like terms are those things that have the same variable and the same power. All right, so you'll notice these three things in between the plus and the minus signs here all have x's, and all of those x's are raised to the first power. So these are all like terms. I can combine all three of these into one term with an x. I'm going to start with these two first. All right, so if I do 4x plus 8x, I get 12x. That's all that means to combine like terms. Now I still have a minus 7x, and over here I still have negative 75 plus 90. All right, then I'm going to go back and I'm going to reevaluate. I still have two things that are like terms. They both have an x. The x is raised to the same power. So we have 12x minus 7x. Well, that's 5x. And then over here we have negative 75 plus 90. All right, so we went from this mess that we started with where we had three different things. We combined them all together to get 5x. And now I'm going to go to the right-hand side, and I notice that I have two things over here that I can combine. These both don't have any x's, so they are constants, and you can always combine constant terms. So negative 75 plus 90 is 15. All right, and then the 5x will just come down because we didn't do anything to that. And now we have a very simple equation to solve here. It's 5 times x, and I want to get this 5 moved to the other side. So I have to do the opposite of multiplication, which is division. So I'm going to divide both sides by 5. Right? When I move something from one side of the equal sign to the other, I have to do an inverse operation, and I have to do it on both sides. So the 5's cancel, and I get x equals, and then 15 divided by 5 is 3. And there's my number, right? If I were to take this 3 and plug it back in up here for all those x's, I would get the same number on both sides. It would make my equation true. All right, let's try this one, right? This one's a little bit different. This one has a set of parentheses in it, and this is where we're going to use a property called the distributive property, or as I like to call it, distribution. All right, so we're going to learn how to distribute the 4 into the parentheses here. All right, so first I'm going to start by drawing my line, and then I'm going to go ahead and get rid of these parentheses using distribution. So I'm going to take the 4 and distribute it to each term inside of the parentheses. And when I say that, I mean I'm going to multiply each term in the parentheses by 4. So when I do 4 times x, I get 4x. And when I do 4 times 5, I get 20. Okay. And then I didn't do anything on the right-hand side yet, so I'm just going to say equals negative 32. All right. And now the parentheses are gone, but I'm going to reevaluate, and I'm looking for anything that I might be able to combine on either side of the equation. So over here I have a positive 20 and a negative 20, and these are like terms, just like what we had over here, so I'm going to combine those. A positive 20 and a negative 20 combine to be 0. So this is just going to be 4x, right? Because 20 and negative 20 combined to be 0. I don't need to write plus 0 over here. And then I still have my negative 32. All right, so now it says 4 times x equals negative 32. So to undo multiplication, I have to divide by 4. And whatever I do on one side, I have to do on the other side. So the 4's cancel. X is by itself. And then negative 32 divided by 4 is negative 8. And there's my number. If I were to take that negative 8 and plug it in right here for x, I would get an equation that's true. I'd get a negative 32 over here on this side. All right, so let's move on to the next goal for today, and that is to learn what a minimum or a maximum is. And it really is just what it sounds like. A minimum would be a point on the graph that represents the lowest point on the graph, right? So if I'm thinking about going up or down, right? So here's my function, and if I want to go to the lowest point on the graph, I would go as low as the function goes, and that would be located right here. Okay, so this point is as low as the function goes. There's no lower point. So we call this a minimum. Okay, a maximum would be the same thing, except you'd be looking for the highest point on the graph. And you'd have to say, okay, well, how high does this function go? And you have to remember what these arrows are telling you. It tells you that the function keeps going forever and ever and ever. So it actually never stops going up. All right, so for this particular function, we do have a low point, but we have no high point. So we have a minimum, but no maximum. All right, so let's figure out how to write that down. As you probably noticed, the minimum is simply a point. So when I write my minimum, I'm going to say minimum, and then I'll just give the coordinate of the point. For this one, it's 2, negative 4. Okay. So there's my minimum, and remember we said there is no maximum because this parabola keeps on going forever and ever. So I'm just going to say none, or sometimes on My Open Math, they'll want you to say DNE for does not exist. Okay. Now, we still want to be able to find x-intercepts and y-intercepts, so I'm going to go look at the graph and figure out where does this parabola cross over the x-axis and the y-axis. So let's look at the x-axis first. Remember, the x-axis is the horizontal line that runs through the middle of the graph. Right? So this is an x-intercept here, and this is an x-intercept here. There's two of them. It crosses over in two different places. So for the first point, the coordinate of this point is 0, 0. The second point has a coordinate of 4, 0. And notice how I wrote that down. An ordered pair, another ordered pair, separated by a comma. This is how My Open Math is going to want you to enter that answer in. All right. The next thing they want is a y-intercept. So remember, our y-intercept is the vertical line that runs through the middle of the graph. So we're looking for where the blue parabola hits the y-axis, and it hits it here. And that point is at 0, 0. This is one of the few instances where the x-intercept and the y-intercept might be the same thing. So notice that an x-intercept is a y-intercept at only this point, 0, 0. Okay? And the other thing you should remember, all intercepts and maximums and minimums should be written as ordered pairs. All right? That means that you have your x comma y complete with a set of parentheses. All right, let's try another one. So let's start with a y-intercept. So we're looking for where our graph over here crosses over the y-axis. And remember that our y-axis is the vertical line that runs down the middle of the graph. So the blue function crosses over the y-axis here. So I'm going to write that point down, and that is at point 0, 4. Okay, so we found the y-intercept. Then we're looking for an x-intercept. All right, so x-axis is located here. I can see that the graph or the function is going to hit the x-axis here at 2, but I'm not going to simply write it 2. I have to say 2, 0, because it is a point, complete with a set of parentheses. All right, now a minimum. Right, so we're looking for the lowest point on the graph. I'm thinking about how high can I go, how low can I go while being on the function. Okay, so the low point, right, I'm going to go as low as I can. So I'm just kind of tracing my function. I'm thinking lower, 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 lower here. Okay, this is the lowest point, and that point happens to be the same thing as the x-intercept. Now the maximum is the highest point. Okay, so I'm looking as high as I go. So I'm going up, 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 and then I start going down. So that means this must be the highest point because I stop going up and then I start going back down. So that's going to be as high as I can go while I'm on the blue function. So the maximum is at 0, 4, and it's the same thing as the y-intercept. Now that's not always going to be true, okay? The x-intercept and the min are not always going to be the same thing, and the max and the y-intercept are not always going to be the same thing. Could be different points, all right? All right, so let's take a look at this next one. We have a different shaped graph here. This is a V shape, and this is created by a function known as an absolute value function. We'll talk about those later, and you might notice the instructions here. Just ignore those. I forgot to delete those from yesterday when I copied and pasted, so I apologize. But our goal is to find x-intercepts, y-intercepts, min, and max from this graph that we're provided here. Okay, so the x-intercepts, again, we're looking at the x-axis, and we're looking for where the blue function hits the x-axis, and I see that happening in 2 locations, located here and here. So I'm going to write down both of those x-intercepts. This one is located at -7, comma, and then I'm going to go to my second one, which is located at 30. All right. Y-intercepts, right? So y-axis is right here. We're looking for where the graph crosses over the y-axis, and that is located right here at -3. But remember, we're not just going to write -3. This would be wrong. We have to say 0, -3. Okay. Then we're looking for the minimum, which is the lowest point on the graph. So low would be down here. This is as low as the graph goes. And I would get this point, right? So I'm going to say -2, -5. So there's my minimum. And then my maximum, right? So I'm looking for the highest point on the graph. So I'm thinking, well, here, let's trace this line and see where it stops. It's going up, 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 up. And the arrow would tell me that it keeps going up, up, up forever, which means that there is no maximum, so we would say none or DNE. All right, guys, that's it. Make sure you get those practice problems done. If you have any questions, shout them out in the Zoom chat. Have a great day.